Hello viewers, this is Karthikeyan, Professor of Electrical Engineering. In this video, I am going to explain you how the power semiconductor devices are being chosen for particular application with respect to its power rating and its operating frequency. For that, let me draw the power spectrum of the devices. In x-axis, power range of the devices is taken, and in y-axis, operating frequency of the device is taken like this. So in x-axis, power rating of the device is taken, whereas in y-axis, operating frequency of the device is taken. Here the range of power is noted. Say for example, this is few kilowatt. This is hundreds of This is about hundreds of megawatt. Now let me note down the range of operating frequency, and this is few hertz starting from 0 to 50 hertz or 60 hertz, and this is 100 hertz. Let it be kilohertz, and this is megahertz. Now, how the power semiconductor devices are being located in this graph, let us see. If you want to have a very few kilowatt power handling capacity, but whose operating frequency is much higher in the range of megahertz, then you can go for MOSFET. If you want to have slightly higher the power handling capacity, whereas the operating frequency is somewhat lesser than that of your MOSFET, then you can go for BJT. If you want to have still higher power handling capacity, but the operating frequency is say more or less same as that of your BJT, then here you can prefer IGBT. So IGBT power handling capacity is much higher than that of your BJT, whereas the operating frequency of your IGBT is slightly lesser or more or less same operating frequency with your BJT. If you want to have slightly higher power handling capacity than that of your IGBT, but whose operating frequency is much lower than that of IGBT, then you prefer GTO. If you want to have power handling capacity in the range of megawatt, whereas the operating frequency is in the range of power frequency, that is 50 hertz or 60 hertz, then you can go for thyristor. So this is the location of power semiconductor devices. I have listed only a few power semiconductor devices, but these power semiconductor devices are mostly used in for various applications. Let me list out few applications of these power semiconductor devices. If you take MOSFET are generally used in power supplies and then UPS, etc. Then coming to BJT, BJTs are preferred for medium kilowatt drives. But these BJTs are being replaced by IGBT nowadays because IGBT battery capacity is larger than that of BJT. Operating frequency remains the same, almost the same for IGBT as well as BJT. So that BJTs are being replaced by IGBT. Coming to IGBT, IGBT are mainly used for industrial drive application and static wear compensators. static wear compensators, and then high power industrial drive applications. Then GTO are mainly used in wind and solar power energy conversion systems. Finally, the thyristor. Thyristor power handling capacity is much larger than that of all other devices. However, the operating frequency of the thyristor is around power frequency 50 Hz to 60 Hz, so that these thyristors are preferred for HVDC systems. And DC drive systems. So these are all typical examples of power semiconductor devices. I hope this video will be very much useful when you choose the power semiconductor devices for particular application with respect to its power rating and frequency range. In the next video, let us see how these power semiconductor devices are suitable for a particular application with respect to its ideal characteristics. Thank you for watching.